Good afternoon. I'm Laura Natali and my tutor is Professor Maria Luisa Merani. During this first year, my research activities is focused on peer-to-peer streaming system and on how to differentiate the service experienced by users on the basis of their interests. Last year, I've witnessed a proliferation of social-based applications and a system that profile users, collecting their likes and dislikes. In parallel, a commercial IP television based on peer-to-peer system as PP Live and TVNs and so on have become very popular. And the flourishing of many channels with well-defined thematic strengths has contributed to polarizing the user's choice towards those offering that exactly reflect their likes. So my idea is to analyze the behavior of web TV users in order to classify them in two groups: high-interest users and low-interest users. Then accordingly modify peer-to-peer architecture of IPTV platform to grant privileged service to frequent channel viewers. When I say privileged service, I mean high quality, low startup delay, and low playback delay. Well, to grant a better service to high-interest users, I propose two modifications of the peer-to-peer streaming system: a new neighbor construction algorithm and a new video chunk scheduling policy. Referring to the former, when a peer chooses a new neighbor, it ranks the possible peers according to available bandwidth, and for the same value of bandwidth, it chooses high-interest peers first. As far as the video chunk scheduling policy is concerned, each peer first serves a video chunk request coming from high-interest users, and if necessary, it allows queuing. Only when all video chunk requests, all high video chunk requests are served and the corresponding queue is empty, then a peer satisfies video chunk requests coming from low-interest peers. About user profiling, I worked with a small data set of user session log provided by Beacon, a small Italian web TV platform. I concentrated only on the sessions concerning the most popular channel, Rai Uno. And I classify its viewer applying fuzzy CMIN data mining technique. Two clusters were built, examining the number of sessions and the average duration of the viewing session for each user. As you can see, green squares represent low-interest viewers, and red points represent high-interest viewers of channel Rai Uno. To simulate the peer-to-peer system, I used an event-driven simulator, and then I modified it. The architecture that I took into account consists of 500 nodes. It is a dynamic overlay. It means that a peer can join and leave the network at any time. To model users' inter-arrival time and user session length, I used exponential law with these parameters: users inter-arrival time 0.1 seconds and average session length 1,500 seconds. I considered an heterogeneous bandwidth distribution among users, as shown in the table. Under this condition, I obtained a resource index that is greater than 1. It means that there is enough bandwidth to distribute video content to all overlay members at the desired rate. Next, I mapped every peer in the peer-to-peer overlay in a pseudo-random manner to one TV viewer in the dataset. So, a peer is either a high or a low interest peer. Now I show you some results. In the first view graph, you can see the delivery ratio that is an indication of received video quality. As you can see, the delivery ratio of high interest users, the green line, is greater than the delivery ratio of low interest users, the red line. But it is also higher than the delivery ratio experienced by the users of the original peer-to-peer system. Next, I computed the distribution of the startup delay. That is the interval between the point in time a peer joins the system until the playout begins. The view graph reports such distribution for two different neighbor construction algorithms, random and the one I proposed based on both bandwidth and interest. In particular, the new algorithm, the dot lines, grants service differentiation as we expected. So high interest users experience lower startup delay than the low interest users. And at the same time, it reduces the startup delay for low interest users, as shown by the comparison between the dot red line and the solid red line. Here I consider the playback delay and comparing its value for different neighbor construction algorithm. The random in the figure above and the bandwidth interest based in the figure below. As you can see, comparing the two figures, the new algorithm reduces playback delay of both categories of users. In particular, for the high interest users, the green lines, you can notice that the playback delay with the new algorithm is reduced about 5 seconds. In conclusion, my peer-to-peer platform modification guarantee a more satisfying service to frequent channel viewers. These are two ongoing submissions that collect my first findings. And this will be my future activity. I will investigate in detail the effect of different neighbor construction algorithms. I will evaluate if the same modification applied in a push-based architecture produce the same result. Then I will consider a peer-to-peer streaming multi-channel system and investigate if some priority policy can reduce switching delay. Thank you for your attention.